Okay, so this is lesson, whoops, excuse me, I'm going a little crazy with my arrows, telling people where to go. Okay, this is lesson 3.4, parallel and perpendicular lines, and I'm Mr. Bloom. Objectives, to relate parallel and perpendicular lines. Make sure you get this to the top of your notes in the objective area. Now, essential understanding. You can use the relationships of two lines to a third line to decide whether the two lines are parallel or perpendicular to each other. So, in theorem 3.7, transitivity of parallelism theorem, or transitivity of parallel lines, we're looking at a theorem. If two lines are parallel to the same line, then they are parallel to each other. Please notice that these markings here are showing that A and B are parallel, thus A and parallel to B, and that these double arrowhead markings inside the arrowheads already are showing that these two are parallel, so B is parallel to C. Since A and B are parallel and B and C are parallel, therefore A and C are now parallel. Okay? So we will be proving this fact in theorem 3.7 in exercise 7. Now, two perpendiculars theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Well, if two lines are perpendicular to the same line, then they are parallel to each other. I wonder if this is connection between converse of corresponding angles postulate. They're two right angles, they're the same, therefore congruent, because all right angles are congruent. Hey, that seems like it'll work. M is perpendicular T, and N is perpendicular T. M and T are perpendicular, N and T are perpendicular, therefore M and N must therefore be parallel. Now, in the two perpendiculars theorem, notice that the introductory phrase, in a plane, proof of the two perpendiculars theorem. Now, keep in mind, I'm going to prove the two perpendiculars theorem, so I cannot use the two perpendiculars theorem. So my first thing in every proof, I've got to read in a plane, R is perpendicular T and S is perpendicular T. R is perpendicular to line T. S is perpendicular to line T. I have two right angles, okay, and all right angles are congruent, so angle 1 and angle 2 must be right angles, and they must be congruent, and they really look as if they could be corresponding angles. So I'm going to use the converse of corresponding angles to help me out. So let's get the show on the road. Let's write down our given. In a plane, R is perpendicular T and S is perpendicular T. Given. Well, we did talk about the fact that when I have perpendicular lines, I make right angles. So angle 1 and angle 2 are right angles, and that is by definition of perpendicular lines. Now, I have 1 and 2 are right angles, and I know from chapter 1, or is it 2? I think it's chapter 2, that all right angles are congruent because 1 and 2 are congruent, so therefore all right angles are congruent, and we got that from here because 1 and 2 are right angles. Now, I know 1 and 2 are congruent, and it's important for us to know. Let's see if I can bring back my arrow. Gosh, I can't get my arrow back here. Hello, arrow, I need some direction. So I'm going to go get an arrow. Okay, let's arrow it up. Boom, there it is. It's back, and there's another one there. Okay, so I got a couple arrows. So keep in mind, I know that 1 is corresponding, 2 is corresponding. These are in the corresponding angles position. So I know by converse of corresponding angles, because remember I'm using that converse of corresponding angle proves lines parallel, and I'm proving R and S parallel. That's what I'm asked to do. So I've got R is parallel to S. Maybe I've got R parallel to S. I had something here, but I've got that. R. So remember, it's R is parallel to S because of the converse of corresponding angles postulate. So that proves the two perpendiculars theorem. But if I were just to use the two perpendiculars, I would have 1. In a plane, R is perpendicular to T and S is perpendicular to because of given. And then 2, hey, R and S is parallel because of two perpendiculars theorem. Now I'm just going to use it in another proof coming up. But first, before we get there, we have solving a problem with parallel lines. A carpenter In carpentry, a carpenter plans to install molding on the sides and top of a doorway. The carpenter cuts the ends of the top piece and the one end of each of the side pieces at 45 degrees, shown here. Top piece at 45, the side pieces at 45. Now, will the side pieces of the molding be parallel? Explain. Well, what's 45 plus 45? If I look at that, I've got 45 plus 45. That gives me 90. Hey, that's a right angle. And 45 plus 45 again, that's also 90. That is also a right angle. Well, and when these things get put together, they'll be perpendicular. And I'll have two sides perpendicular to the top side. So, two perpendicular theorem, the sides will be parallel. Hey, it'll totally work out. That's cool. Now, moving on. Our next thing is the perpendicular transversal theorem. Well, if in a plane, that might be a theorem. If a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. If a line is perpendicular to one of two parallel lines, then it is perpendicular to both parallel lines. Note the introductory phrase again, it is in a plane. Okay, so it's important to keep in mind the perpendicular transversal theorem states that the lines must be in a plane. The diagram at the right shows why. In the rectangular solid, it's line AC. So if I got line AC, let's highlight that in blue. If I got line AC and line BD, let's go BD. I got BD there, and I got AC here. Are parallel, okay, and they are. EC is perpendicular to AC, okay. So EC is perpendicular to AC, but it is not perpendicular to BD, and the reason why it's not is they are not in the same plane. They must be in the same plane for that to exist. In fact, line EC and line BD are skew because they are not in the same plane. Okay, in problem 2 here, proving a relationship between two lines. In a plane, C is perpendicular to B. C is perpendicular to B. And B is perpendicular to D. And D is perpendicular to A. Okay? All right. Right now, I've got to see what they want us to prove. They want me to prove that C is perpendicular to A. Well, I know I can show that C is parallel to D because both C and D are perpendicular to B. And since I know that D is perpendicular to A, and I just shown that C and D are parallel by two perpendiculars theorem, I can say that C is perpendicular to A because since D is. So let's talk about it that way. I know my given, okay, in a plane, C is perpendicular to B, B is perpendicular to D, and D is perpendicular to A, that's given. And I just talked about the fact that I know C is parallel to D because two perpendicular theorem, two lines perpendicular to the same line makes them parallel, okay. Now, since D is perpendicular to A, they told me that in the given, and D and C are parallel by perpendicular transversal, I know that C is perpendicular to A. So we're done with that proof, but let's see what else they got here. In problem 2, could you also conclude A is parallel to B? Well, I totally could, because here I could totally prove that A is parallel to B because of the two perpendiculars theorem, okay, from that given. So I know that, and that is totally cool. And we are moving on. So transitivity of parallelism theorem in a plane, if a line is perpendicular to one of two parallel lines, then it is also parallel to the other. If A is parallel to B, A is parallel to B, and A is parallel to C, and A is parallel to C, because I know those markings, then I know B and C are parallel. B and C must therefore be parallel. So all three of them are parallel together. Gosh, this looks like something that was on the very front page of our notes. Let's see where that is. Transitive parallel. Wow, that's the same thing. Check it out. Crazy! I just repeated myself. I apologize. You guys probably don't have that on your notes. So let's finish this thing up. So it's a summary. Use the lesson's objectives in your notes to reflect on what we learned today. The objective to relate parallel and perpendicular lines. Keep in mind, go inside the front cover of the chapter 3 notes and see what you know new today and see what you've got left to know. I hope things are going well. If you have any other questions, please locate your local geometry teacher. Have yourself a fantastic day.